In this lesson, we're going to talk about the skewness and the mean, median, and mode. So we're going to look at some graphs, and when you're graphing histograms or any statistical graph, some of the characteristics that we're looking for is the spread, which shows us the variability in the data, and then another thing that we look for is the shape of the distribution. Okay, and when we talk about the shape of the distribution, we usually describe it by saying how many peaks there are in the graph, if there's any symmetry, if it's skewed, or if it's uniform. And so we're going to go through some examples of different shapes of the graph and describe them, and then we're going to eventually make a connection and some generalizations on how that relates to the mean and the median. All right, so the first graph we're going to look at is this histogram. And so if I imagine that I connect the tops of all the bars, I get something that's called mound-shaped, which sometimes you'll also see it called bell-shaped. And this is where we have one peak, where it's the highest of the graph. And then we call it symmetric because I can imagine that if I draw a line down the center and I fold it along that line, it's going to match up on both sides. It's like a mirror image. Now, in most math classes, when we say something is symmetric and we're talking about a graph or a function, it has to be symmetric for every single point on that graph. When we're talking about it in terms of statistical graphs and data, a lot of times we just say it's roughly symmetric, because if we're collecting data in real life, nothing is ever symmetric. It's very rarely that you're going to find symmetric data. So usually you'll see it described as roughly symmetric. So just keep that in mind. Now, when we look at this next graph, this is called skewed left. If I imagine that I connect the tops of all those bars, so I imagine that shape, you have a mound on one side, and then you have a tail that's going in the other direction. And when we're trying to remember the difference between something that's skewed right or skewed left, the way I always remember it is whatever way that tail is pointed, I imagine that there's an arrow on the end of it, and it reminds me that this is skewed left. This is not symmetric because I can't cut it in half and it look like a mirror image on both sides, and I would call this having one peak. Now here we have skewed right. This is actually a typo. You can cross that out. Skewed right. And that's basically the same thing as skewed left, although except for the tail is pointing in the other direction. So if I imagine that I connect all the tops of my bars, I have one peak or one mound in the left, and then I have a tail that's pointing to the right. A lot of times you'll hear the word bimodal, and bimodal just means you're going to have two peaks. So an example might be something like this. Now the book focuses on these first three examples, and I pulled these graphs from the book, so you'll see those in there. But the OpenStax book does not cover the bimodal, uniform, or multimodal, so I wanted to make sure that I cover these as well. Multimodal just means that it's more than one peak, so bimodal falls under that umbrella, but usually if it's more than two peaks, we call it multimodal, so something that has three peaks, something like that. Now, if we have a graph that is uniform, that means if I imagine all my bars come up and they're about the same height. Now again, in real life, you're rarely going to have data that is perfectly uniform or data that is perfectly symmetric. So most of the time you'll have bars that are close to the same height but not exactly the same height. But when you have something that looks like this, where all the bars are pretty close together as far as the height, that's called uniform. And this is also symmetric, but it has no peaks. It's the same across. And that's it for the basic shapes of what you're going to run into. Now, this example that we have that I pulled from the book is going to help us draw conclusions on how the shape of the graph is related to the location of the median and the mean. So we're going to draw some graphs for this example. So we have 3 sets of data here, one for Terry, one for Davis, and one for Maris. And so in the first part, we're supposed to make a dot plot for these 3 data sets, and then we're going to look at the shapes of them. Now, I haven't talked about a dot plot yet in the class, but a dot plot is basically the same thing as a histogram, where each category is one value and you count it by making dots. So the first graph, we'll do Terry first, and I'll make each tick mark worth 1. I think these are all values that are under 10. Let's see, we have a 1 for Terry, just 1, 1, so I'm going to make a dot over 1. Terry has in her data set 2 2s. One thing about a dot plot is when you make your dots, you want to make sure that they're equally spaced so that the graph isn't misleading and give you an inaccurate shape. Okay, so for 3, it looks like there's 4 3s, so I'm going to make 4 dots over 3. Then there's 1 4, and then there's 1 9 and 1 7. If I imagine I connect the tops, then that looks like it's going to be skewed right because my tail is pointing to the right. Okay, for the next plot, we're going to do Davis. Okay, so for Davis, Davis has 1 2 3 4 5 3s. 1 2 3 4 5. He has 2 1s. He has a 2. And he has 2 4s. When I connect the tops, that looks like it's skewed left. I have what looks like an arrow going to the left. That tail goes that way. And then let's draw Maris's data last. Okay, Maris has 1 2. She has 1 2 3s, 1 2 3 4s, 3 6s, and an 8. Now, if I imagine that I put those together, that to me looks like it's symmetric. I'm not sure if I would call that mound shape because I don't have anything in the middle, but that would be definitely symmetric. Now, let's see what the next part is. It says calculate the mean for each data set. That I feel fairly confident that you guys can do without me walking you through those steps again. So let's just list down what those means are. For Terry, when we add up all the data values and we divide by the number of data values, we get that Terry's mean is 3.7 and Davis's mean is 2.7, and then Maris's mean is 4.6. Let's take a look at that on the graph. So I'll draw the mean in this light blue. So on Terry, the mean would be at 3.7, so somewhere here close to 4. On Davis, it would be 2.7. And then on Maris, it would be 4.6. So pretty close to 5, somewhere in here. Those are the means. Let me highlight that down here and make a key. The blue is the mean. Okay, now for part C, we need to do the median. When we look at each data set, the median is going to be the center value or the average of the 2 middle if you have an even number. And when we find the median for each data set, we find that Terry has a median of 3. Davis has a median of 3. And Maris has a median of 4. Let's draw the median. Let's do, I don't know, purple, something different. So we're going to do the purple is the median. Okay, so when we draw the median on here for Terry, hers is going to be at 3, and then Davis is at 3 as well. And then Mavis is at 4. Okay, now for part D, it says describe the pattern you notice between the shape and the measures of center. So this is where we're going to make our connection with the shape of the data and the median and the mean. So the first thing we notice is that the mean and the median is always going to be close to that mound if there's a peak. Okay, because that's supposed to be where the data is concentrated. So, but the other thing that we need to point out here is that when the data is skewed, the mean is going to get pulled in the direction of whichever way it's skewed. So, for example, if we have a bunch of data of test scores, and most of the test scores are high, so they're in like the 80s and the 90s, and then you have a couple of lower values that are maybe in the 20s or 30s, you're going to have something that's skewed left because most of the data is going to be on the right where you have your higher values, and then you have a couple of values that are off way on the low end to the left. So you're going to have data that is skewed left because that tail is going to pull to the left for those couple of smaller values. And the mound is going to be where you have the majority of the data values. So when you go to take your mean, those two smaller values is going to pull your mean down. If you didn't have those two smaller values in your data set, then your mean would stay in the 80s and the 90s. But because you have a couple of values that are going to pull that average down, that mean is going to get pulled in the direction that it's being skewed. And the same thing goes when the data is skewed right. If you have mostly data that is lower, where it's all concentrated in lower values, and then you have a couple of high values off to the right, your data is going to look skewed right because you have that tail with those fewer values on the right, and then your mean is going to get pulled from the center out a little bit to the right because those higher values are going to make your mean value go up. So that is the major idea of this section, is that when you're looking at something that has a single peak, that the majority of the data is going to lie in that area of the peak, and your mean and your median is going to lie in that area of the peak. And then your mean is going to get pulled in the direction whichever way it's skewed.